Okay, in this video, we actually do an example of logistic regression using Excel. We're going to follow the steps for a particular problem of calculating these logits. And again, that can be pronounced a lot of different ways, but that's how I pronounce it, and that's how I've heard it pronounced, logits. We'll convert these logits to odds, convert odds to probability, use an add-in to Excel called Solver to help us maximize the probability of capturing events. And um, so that's what we're going to do. So it's going to be somewhat lengthy video, longer than what I normally do. Before we go down the path, I want to talk a little bit about probability and odds because the file that I showed you, or the example, I tend to switch back and forth because we have to go from logit to odds to probability. So here's a real simple example of how you can move from there. So if I have a probability, so first of all, a probability is a number between 0 and 1. If you want to show it as a percent, that's fine. So 90% is the same thing as a probability of 0.9. They mean the same thing. But if I have a probability and I want to convert it to an odds, that's the formula to do it. So you just take the probability divided by 1 minus the probability. So if you look at the formula for this, I take the probability, divide by 1 minus the probability. So if the probability is 0.9, that means that the odds of that occurring are 9 to 1, 4 in favor. If the probability was 0.6, then the odds of that happening are 1.5 to 1, or 3 to 2 if you wanted to think of it that way. If the probability was 0.5, well, then you get an even 1 to 1. So that's how you can think of converting probability to odds. And the same thing, if you have odds, you can convert it back to probability. So if my odd is like 4 to 1 in favor, what's the probability of that occurring? You can use this formula. It's the odds divided by 1 plus the odds. So I coded that up. You can see how it does. You take the odds divided by 1 plus the odds. So if the odds of that occurring are 4 to 1, so that's in favor of, then the probability of that occurring is 80%. If the odds are very unlikely, so let's say 0.25 or 1 to 4, it's another way to say that one, then the chance of that occurring is only 20%. Okay, so here's the data. What we're trying to do is predict. We've got it's real estate data. We're predicting. We've got data that looks at a particular person or family where this was the income, this is the age of the person who makes this income, and this is where the house is. And we have data to see if that person ultimately bought that house or not. So this particular person where a house located in this zip code, they did not purchase a house. If I scroll down, we have some where this person with this income, this is their age, and it's in a different zip code. We only have 2 different locations of houses. So there's a dummy variable representing 2 locations. 0 is one location and 1 is another one. And then zeros and ones on column A are the likelihood that they're purchasing the house. So our dependent variable, our Y variable, is binary. It's not a continuous. So we cannot use regular regression. It would be a misuse of that. So let's use logistic regression. So what I've already done, what you already have is a template that you can just fill out, extend. So let me just walk you through the template. If you don't understand the math, that's okay. All you have to do is copy and paste. But let's work our way through the template. The first thing is that these are the coefficient equation, coefficients for the regression equation, or the logit. So these are the coefficients for the logit. There's the intercept, the income, the age, and the zip code. They're all set to 0, just like when I was doing this example over here, and I set these initially to 0. I don't know, I don't have a scatter plot that I can look at for this one. So I'm just going to start them out at 0. Here's the data that I just copied over. That's the exact same data that was here. So this is the given data. So what did we do to build a logistic regression model in Excel? The first thing we did was calculate our logit. So look how this works. It's pretty easy. I would say it's a sum product, but it's the intercept plus the coefficient of income multiplied times income plus the coefficient of age multiplied by the age for a particular record, and then the coefficient of the zip code times the zip code. So that's what you get with that, and that's called the logit. So remember the steps is that we have to convert logits to odds. So how do I do that in Excel? I took this logit, which is evaluated to 0 because it's 0 plus 0 times a number plus 0 times a number plus 0 times a number. Well, that's all 0. So how do I take that and convert that to an odds? Here it is. The odds is E raised to that power. How do you do that in Excel? That's the formula. You don't need to know that. You just need to use it. But that's equivalent to taking E raised to this expression. E raised to that expression. It's E raised to the logit equation right there. Now that I've got the odds, I can convert these odds to probabilities. Now, if it's a 0, I want to find the probability that they didn't purchase. And if it's a 1, I want to find the probability that they did purchase. Well, that's really what column I is doing, but we start by calculating a probability that they did purchase from the odds. So remember, when you go from probability to odds, you take the odd divided by the 1 plus the odds, and that gives you a probability that they did purchase. But I don't want that if they didn't purchase. So I want to know what would be the probability that they didn't purchase. That's what you get here. This is a probability that the model is determining whether they purchased or didn't. So column I is what we wind up doing. Now, what I really want to do is take this times this times this times this times this, and that becomes what I'm trying to maximize. That's called the maximizing the probability of success. I want to take all those and multiply them together. But there's a trick that I can do because that becomes a really, really, really small number. And there's a trick that I can take the log, the natural log of that number, and add these up. So if I add up all these, that's what this is. So it's just it's an algebra trick, understanding of trig functions and how powers and natural logs work. And this is, if I can make that as big as possible, then it's going to increase my likelihood and increase the probability that that I've accurately represented what happened. And if this probability turns out to be close enough to the cutoff, then I'm going to say it's a correct prediction. Okay, so the first thing I'm going to do, so let's use Solver to do this. So if I look under Data, Solver, what I'm trying to do is maximize, in this case it's a maximize this likelihood, which is in cell I2. Now, which cells am I going to change? If I leave it at A3 through D3, it has complete control over all these coefficients. But what it's interesting is that we're first just going to give it control all over the intercept. That's it. Okay, I just want to do this as an example. So it's only controlling the intercept. That's all it has value over, but it's trying to make that. And I hit solve. It found a solution. Look what it did. It set the intercept to 0.451. The likelihood was a number smaller than that, and it's getting bigger. And look what the number of correct out of how many instances? Out of 36, it accurately predicted 22 just by fixing the intercept. Okay, so that number, copy. I'm going to drop over here into this, which I've already done, but I'll do it again. Now I'm going to add the intercept and the income. So now I'm going to build a model where I'm going to try to maximize my likelihood by changing the intercept and just the and the income. So I'm going to try to predict if someone's going to purchase, say, a house based on the income and the intercept. So I'm going to go back to my solver, and now my cells that I'm going to allow it to change are 2. And I'm going to hit solve, and look what it does. It was at minus 24. Again, it's trying to make this as big as possible, so it's trying to get from being negative, and it went from minus 24 to minus 18, so it's getting bigger. And it went from a prediction of 22 to 28. So now this is whoops. Just want the value, pay special the value. So my log likelihood, or what I'm trying to maximize, it went from minus 24 to minus 18. And I've got a percent correct at 78%. Well, now I'm going to do it again. And now I'm going to let it change the intercept, the income, and the age of the person. And hit solve. And yet again, it went up again, but not by much. Not by much. So what is that telling you? You can see that the log likelihood from here, it went from minus 24 to minus 18, but then minus 18.6 to minus 18. The age of the person is probably not that important because it didn't really move the likelihood much up at all. Well, I'm going to add the last one, the location. So this is kind of jumping to now this is the final step. I'm going to let it change all 4 of those, again, to maximize my likelihood. And now I jumped a huge step. I went from minus 18 to minus 14, so a jump of 4. And I'm now at as good as, this is the best I've done, where my percent correct is 81%. So that means that you can see the person who purchased a house, who didn't purchase a house, my new model using this logit says that the probability that that person did, that based on the data, the probability that they didn't purchase a house is 98%, which is almost guaranteed. Does that make sense? So you can see it doesn't always get it right. Look at this one. This person only made $71,000.49. They bought a house in zip code 1. They actually bought a house, but the model said the probability that they would buy a house is only 11%. So it did not get that correct. That was a mistake. So we're looking for a bunch of 1s here. When it's a 1, that means that it correctly predicted. This person who did not purchase a house with these incomes, the likelihood that they did not purchase a house is 79%. So not as high, but it did get it correctly, where the cutoff is if it's over 50%. So when this number is over 50%, we're going to say it correctly predicted it. It's better than flipping a coin. So we can talk about this later. I'm not too worried about this. I want you to be able to take this model and extend it. So how would you extend this model? Well, you can add rows, because all you have to do is copy down. I could copy this down. Let's say I had more data. So I've added more data. This is just made up data, but I don't know anything about this, and this is what really happened. So if I had more data, see how these all copied? And then I would go back up here. This log likelihood would need to encompass everything, so I can make it do a larger data set. And that's it. And then you rerun the model. So you can modify this to rerun the model. You could add another variable. Right now we've got 3 variables, but you could add a 4th one. If you wanted to add a 4th, I would probably add it in between. So if I wanted to add another one, I would probably click on this, do a right-click insert, and add something in between, because the logit, and then you would have to add that other variable. But let's say we had another variable, which was the condition of the house. Condition, and we only had and this is the variable, and we just had a variable of it's either we had some variable that said it was what its condition was. I don't really know how you would do that, but that's how you could add to this. Okay, that's enough information, I think, for you to be able to apply this template. Thank you.